Hey y'all, we're going to work on a couple of inequality problems in preparation for exam 1. We're going to look at 2.6, 1E, and 2.7, 1B. Let's look at 1E first. You want to find all solutions of 2 minus 3x all over negative 5, absolute value of all of that, is greater than or equal to 2. The goal is going to be to get in the form of, x is greater than or equal to this, or x is equal to less than or equal to that, or whatever. So first off, one handy observation is to note that this is the same thing as just being over 5, because absolute values don't care about negatives, right? At least negative values by themselves. Absolute values don't care about multiplying by a factor of negative 1. Now what would be a good idea would be to multiply both sides by 5. Okay, so we're going to get 2 minus 3x greater than or equal to 10. And at this point, we're just going to add 3x to both sides, subtract 10. I think we're going to get negative 8 greater than or equal to 3x. I think we can see this implies that x is less than or equal to negative 8/3. Right, if I just sort of flip everything. Okay, so that's our answer. X is less than or equal to negative 8/3. If we were to draw this on a number line, that's what it would look like. Or you could also write the solution set is negative infinity to negative 8/3. Whoop, I guess we should say inclusive. Okay, that's how you do that problem. Now for 2.7, 1B, see if we've got enough room to do this one, right? First of all, this one I think was supposed to be less than or equal to 0. Now remember, what we want to do here is we want to identify all zeros in the numerator and also everything in the denominator that would make the denominator 0. Those are our values of interest. So what we want to do is we want to consider quite a few values here, right? X equals negative 3, 2, negative 4, 2 again, right? Because this can be written as x minus 2, x plus 2, and also negative 2, right? Okay. So now what we're going to do is we're going to draw our number line. We're going to mark these values. So we've got negative 4, negative 3, negative 2, positive 2. Again, they don't need to be to scale. And we're just going to plug in a value in each interval. Okay. So let x equal negative 5. What's that going to do? If we plug that in here, that's a negative. This is always going to be positive, right, because it's getting squared. And I guess it's going to be plus 5 anyway. So a negative times a positive, the numerator is going to be negative right on top. Divided by plugging in negative 5 for x here, we get negative. And then here we're going to get a positive. So we have a negative over a negative, which is a positive. So we get a positive for that one. Nothing really nice about this one. We have to plug in x equals something like negative 3.5. Let's see what that gives us. Well, this is going to be negative, positive, right? That's always going to be positive. Positive, because 3.5 is a little bit less than 4. And positive. So this is going to be negative, right? Because we get a negative divided by a positive. Now another not so nice value, x equals negative 2.5. Here we're going to get positive, 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 and 2.5 squared is bigger than 4, so this is also going to be positive. Right? So it looks like everything is positive here. Next up, I would certainly choose x equals 0. You could do -1 or 1 if you wanted, or anything else between -2 and 2. And it looks like we're getting positive, 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 negative, right? 1 minus 4 is -3. So this is going to be negative, right? A positive over a negative. Last but not least, we're going to plug in something bigger than 2, like x equals 3. Positive, 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 positive. So remember, we are interested in the values where we have something less than or equal to 0. Now, before we write our solutions, maybe note that x cannot equal -4, 2, or -2, right? Because those are the values in the denominator. Okay. So our solution set is, now you can write x equals or x is in if you want, I guess. Maybe not x equals, don't write that, but you can write, so we want to say it's -4 to -3 inclusive, right? Because we want the negative regions, right? Union -2 to 2 inclusive, but remember, these are prohibited values of x. So really, we should change that to not being inclusive, not being inclusive, not being inclusive. Okay? So what we're left with, just to be a little clearer looking, that's our answer. Right, and if you wanted to draw this on a number line, if I asked you to draw it on a number line, which I didn't ask here, but if I did, then it would look something like this. That and that. The way that the book draws it looks a little bit more like this. Either way is totally fine. Okay, that's how you do them. Thanks for watching.